I think it started. Yeah. Thanks, Jan. Okay. Let's connect to our instance. Let's first open Cloudera Manager. If you guys want to try it and you have your systems ready, right, you can also start your Cloudera Management cluster and just keep on doing the steps. Although I think don't do it because most of the things today we'll be covering is theoretical, so I don't want you to spend money. But you can just see what we do and then continue at your end. Okay, I think that would be good. Okay, this has started. Okay, these two are also started showing bad health, but for now we can ignore that stuff. Okay, let's connect to Beeline. I EC2 user at the bit. Okay, so we have connected to Beeline. Let me check what all databases we have. Oh, okay, so we created a DB last time, I remember. Let's use this one. Okay. Underscore DB. Okay, now we are into this DB. Let's check the tables. Show tables. Okay, so there are a few more commands. So this was like how you recognize what all table databases you have and what all tables you have. I guess we did that last time as well. Now there are few also like more commands if you want to understand what this table, what all columns are actually there in this table, right? So one command for that is show create table, followed by the table name. So if I want to run this on, let's say, this table, now what this command does is it's give you the create statement. So at the time of creation of a table, what statement did you tried to create a table? The complete syntax of that table that includes the column of this table as well will be shown by this command, show create table. Very simple command to understand what all columns are there and whether my table is an internal or external table, what are the partitioned columns. All such information about any table you can get by this command, show create table. If we run it, so this is the exact create statement we used last time. Some of the properties are added by itself. For example, there's a property called table properties, which gives us the time at which this last time this table was uh, like it was accessed. So this is an epoch time. Like every time on Linux servers is shared in terms of an epoch number. So this is so any date or any time is converted to an epoch number format, which is this. Okay, so if there's a certain command for Linux, if you want to convert it and want to see what exactly is that time, so that's available after a date command. Okay, and apart from that, it gives us a location, and since external is not showing up here, so that means this is at the time of creation of this table, it was made an internal table, right? So over here it shows create table. But if we like do this same command on the external table that we created, so this was internal and this is external. So you'll see there's an external keyword. I think you all also tried it from yourself and tried to see. Now just try to run this command on your tables as well and understand what are other like columns or anything were added while you created that table. Okay, so we only use a statement like create this table. We provided the columns of that table, then we gave it a location, while the rest of the things, as you can see, the output format, input format, all of these things were added automatically by the Hive, and some of the table properties that were computed by Hive itself were like number of files, number of rows. Since we haven't added anything to our table yet, so that's why it's giving us a number of files equals to 0 and rows and everything else is 0. And this is the last time we access this table. Okay, now there is another command for the same thing. Let's just check the table again. Okay, so another command to do the same thing is describe. Now describe won't give you a create statement of any table. So when I say create statement, what was the statement we used at the time of creation of that table? But describe, it will give you a summary of or description of your table. Okay, so you won't see something like create external or create internal as we saw while we were using show create table, but some other properties. Let's see what all they are. Okay, so whenever you run describe, you'll see it gave you the column name, its type, and it's like if any comments that you were added that we added at the time of creation of table. Since we haven't added any comments, so that's this column is empty. Also, there is another option to give you another or like more information. So this is something like describe followed by formatted. Describe formatted followed by the table name, and this time not just the column and its data type, we also get some more information like which all did so there's a comment that tells you the detailed table information. It gives you the database on which this table was created, who is the owner. Right now we haven't assigned any owner, so it's giving us anonymous. Creation time, when was this table created? Okay. Access time, okay, that all these things are unknown. Location, since it's an internal table, but it's still giving us a location, because all internal tables by default tend to go in user Hive warehouse directory. That's always it's a default thing. Now internal tables are also known as managed table. Okay, so that's why it's giving us table type as a managed, so it's an internal table. Then there are certain properties like transient. This thing is something like quite similar to this one. And there are the third library input format. So input format, when they say what exactly is the data inputted into this table form and how exactly this data should be outputted, would be an output format for this table. Okay, and we haven't created any buckets, so that's why it's -1, and this sort of thing. So this is how you can describe the contents of a table. And also in terms of, let me give you example for the external one. How exactly is that different? Okay, so over here you can see the table type being external table. Internal table are also known as managed table. That's why it was appearing as a managed one in the previous case. Okay, so these are the commands how you describe a table and how you see. Now, how do you check the data inside a table? What exactly is the data present? How will you do that? So for that, a very simple command could be a select query. So you want to select all the elements. So for all the elements, you use star, select star from the table name. So my table being Sahil. What was my table name? Hmm. So select star from Sahil table will throw output of all the contents of my table. Okay. So if I do this like this, so okay, probably its path is external, and what's exactly its path? Okay, temp Hive. So right now it's giving us me an error because I haven't loaded any data yet. Similarly would be the case with my internal table. If I just remove this part, that would become my internal table. And you can see there is no output showing up because we currently don't have any data in our table. Now let's just quickly add data to our table. So I have opened two tabs. One I will use to connect to my beeline. Okay, use Sahil underscore db show tables. Okay, create table. So I want to check what all columns are exactly there in my table. So I'll devise my data similarly. Show create table. Okay, so this table has a name and an age column. Let's just make, okay, so we'll make a table, we'll make a data which has a age and a name and a age column. So as you have one HDFS, let me vi a file, let's say data doc text. So first being a name, let's take any random number, random name and ages. Okay, 3 columns are fine. Now once we have created this data, let's just put it in any directory you want to put in HDFS. So I want my table to load data from an HDFS path. So let's just put it with HDFS dfs hyphen put. Evan, what is the other command to put data in any HDFS path apart from put?
Give me a second. Copy from.
Yeah, right. Copy from local. That's right.
Yes.
Okay, so I have been putting this data into the temp folder now. All right. So let's just check also whether Hive data is present. So we'll check by using HDFS dfs ls slash temp and then our data path, which is this. So now I can see my data is being present in the temp. Now the command used to load data is load data in path. After in path, you have to mention the path from which you can want to load your data from. So I have actually copied my data in slash temp and this is my data name, right? So load data in path and then I'll write overwrite. So what overwrite will do is it will remove any previous data that was present in my table. You can remove this command as well if you don't want to overwrite and if you want to append data. So for example, since we are writing for the first time, I cannot, I think I can ignore this option for overwrite as well. But in future, if I would want to replace the data completely from that table, right? So I will use this overwrite option, or else if I want to just keep on adding data to my table, I will not use this overwrite option. Okay, but right now I'll be using it. So for clarity, load data in part, overwrite into then your table name. So I'll write this first in the table. Okay, overwrite into table. Okay, I think we created that table with the EC2 user. That's why it's giving me an error. Let me create another table. Sahil. So this time I'll be creating a table which is similar to my previous table, which was Sahil table. So let me rename this table. Let me name this table as Sahil table v2. And there's another option. If you just want to copy a table, right? If you want to copy exactly a table into a different table, into a table with different name, right? So you use a keyword like. So I will be making create table, Sahil table underscore v2, which is quite similar to Sahil table. Using this, now if I run the command show tables, you can see another table is created, and the contents, like the, if I do the describe over it, it would be quite similar to what describe for Sahil table was showing. You can see string and ends. And also let me check what is the owner this time. So last time it was giving me an error. Let me just show you that error also, so that you are not confused why we make a new table. Okay, so over here you can see when I was loading data, it gave me error, something execution error failed, unable to move source path. So he was not, the Hive was the not able to copy the path to the destination, which is my internal table path. Okay, and the reason that it told was permission denied, sticky bit user anonymous. So my table was owner. If I do a describe of my table, you will see that the user, the owner of the table was showing anonymous, right? I also like discussed it before. I think we made this table with the EC2. We logged into Beeline console with the EC2 user itself. So that's why there was no user assigned to it. And it wasn't able to copy that part. It was giving me a permission denied because my table was owned by an anonymous user, and the data over which, over the path that we put, right, it was owned by HDFS. That's why it was giving me that error. And I had to make a similar table because this time I have like logged in with the HDFS user itself. And if I do a describe formatted, let me see who is the owner of my this table right now. Okay, when this is showing me anonymous. So what we can do is, let's just give it a permission of others. So this time the other is only given a permission of read. What I'll do is I'll give the other person. So this would remain same. So this would like R is 4, W is for 2. So 4 plus 2 is 6 for the owner, which is HDFS. 4 for the group, which is super group. I don't mind it to be as it is. So this would remain same, 6 4, but this one I want to give read, write plus execute, so that would be 7, 6 4 7. And now if I do an ls, you will see read, write and execute also appearing. And let's just check if we are now able to load the data. Okay, load data path, let's see. Okay, this is not allowing it. Let's just try and change it to anonymous. Okay, so I have changed the owner. All right. So there was some like, I don't know, but how my table started making with this anonymous user, but since my data was having HDFS user, right? So it was giving me permission denied. So what I did was, first I tried to give it a permission so that others can also read and execute, but that didn't work. And finally, what I had to do was to change the owner of my data to anonymous, which is the same as the owner of my Hive table. And now when I tried to load data, we were able to load that data into the table. Let's just quickly make this command available for you. Okay, loading data. Okay. And now if I try to do a select star from my table, you can see the data that we added is able to see. But what problem that we see with the data is my age is not separated into the other table, into the other column, right? Now this reason being because the delimiter, how my table assumes whether the everything after comma is to be added to the next column, we haven't mentioned it at the time of creation of our table. Okay, so there is another option, so to provide that delimiter. So in the create statement, let me open the same create statement. Let's just use the same create statement, and this time we'll be providing it a delimiter as well. Create table. And then followed by row format. So these are like new things you have to mention when you are creating your table. So we'll say it like row format delimited. What it means is each row that is to be added to the table is assumed to be delimited. So row format will be delimited. And fields, how are the fields terminated? So when I may say fields terminated, each thing after a particular option that you mention will be considered as a separate column value. I'll explain it how. Fields terminated by, this time I'll tell it that anything that ends with a comma would be a value for a particular field. Okay, so row format delimited, fields terminated by comma, followed by rest of the things we can like ignore. Store format, input format, let it be the same. Location, since it's an internal table, let it be the same as well. Just need to give it a new name this time. V3. And now when we make this table, okay, so we had missed a in fields terminated, and now we have made this table and we have made it aware that anything in the data that ends with a comma is actually a value for the previous table. Show tables. Okay, so now this time we'll be adding the data into our V3 table, and let's see if that data is. So every time you load data into a table, right, this data gets deleted from its path. So this data, when we have like when we loaded this data into our previous table, Sahil underscore table, this might have already been removed from the path. So if I do an ls right now, you can see that there is no such file or directory. So every time you load a data, the same data gets removed from the path and it's actually placed into the location of your table. So what I'll do is I'll again put, since this data.txt is already present on my local system, so I'll put it again into the temp folder and then use the again chown because I'm expecting the data is still by HDFS user. So let's just again make it chown anonymous, and now just put our data into the v3 table. Okay, and if I now do a select star from v3, so now you can see that anything after a comma was actually interpreted by my table as a separate column value, and this is quite different from how my table earlier table looked, which was this. So in over here you can see that the table was not able to understand what is exactly after comma. So everything of every line of that table was considered as a value of the first column only. Okay, because we haven't mentioned how the row format needs to be delimited and what is the termination of a field to be able to understand. So all these things we were able to describe by this statement: create table followed by a table name, the value, the row, sorry, the column name and types, and then this statement, which is important. So it shows row format delimited, which means every row is to be considered as a delimited row. Delimitation is, uh, wherein each row is considered to be combined of different values, and then how do you describe that a value is ended. So for that we mentioned that all the fields should be terminated by a comma, or even instead of comma, if you can place, if you want, like, since we had created this table, this data with comma separated, if I just make it, let's say, pipe separated this time, or any other field, let's say pipe separated. Okay, right. So this time my delimiter is pipe instead of comma. And if I now save this file, let me place it again in the temp and chown it again to anonymous. Okay, now let me also create a table v4 this time. So this time what I'm going to do is, right, I'm going to change this delimiter to the pipe which was in my this data. Okay, so if I make it, let's say, table v4. So this time if I make it, if I don't give a pipe separator over here, right, it would follow the same approach of putting this complete line into the first column, which is name only, and it will not segregate the other 25 and whatever the ages are into the second column. So that's why I have to mention what exactly will be the delimiter in my table data. And now just if I just load data in the same path, so this is the same table, but it's the same data, but the delimiter is changed this time. Let's put it into v3 first. You'll see that since the v3 had a delimiter comma, okay, earlier, so you can see that it was not able to understand what this second option meant, what the second data meant, and it put it into the same column, which was the first column itself. But now just quickly put this data into the v4, over which we have mentioned the delimiter being a pipe this time. Sorry for that. First put the data. It has been moved out. Let's place it again. Now try to load it. Now try to select star from it. So this time data was able to segregate properly into the columns, with the name column having the names and the age column having the ages. So this is how you can load data into an internal table. Similarly, you can load data into any external table as well. Okay, so if I make another external table, let's say Sahil external table. Let's the delimitation be the same as well, but this time we have to mention the path as well. Every external table has a different path from user Hive warehouse. So I'll mention the path, let's with the location. Let's say I mention it with slash temp only, slash temp slash my table name, which is this. Let this be the path of my new table. Since v4 is already present, we have to give it a different name. I'll make it external v2, external v2, and okay, let's make it, and again put the same data into the directory. Make it anonymous and load data into the external table this time. So external v2, and let me just check the contents. So the same command is to be followed for the external table to load data, but I'll show you what exactly lies the difference between an external and internal. Actually, what is the difference? So select star from, this is my external table. So yes, data is present in my external table as well. Okay, now just a quick difference of why we tend to make external table and why exactly it is different from an internal or a managed table. I think Sharif has some difficulty. Let me check it out. Okay, he can join like later as well. Okay, so let's see our tables first. Okay, so this was an external table that we created, and this is the internal table. Let's just quickly check what exactly are the location over where the data of these tables were present. So for this table, if I do a create, show create table followed by a table name. Oh, show create. So this is the path of my external table. Let me check what exactly is the data present. So I'll do an ls over this path, ls, sorry. So this is the path of my table, and you can see the data text that we inputted in that table is present in this path, which is the external tables. Similarly, let's check for show create table for an internal table, v4 this time. And as I told you that the path to any internal table is user hive warehouse, right? Let's do a ls over this as well. And you can see the internal table also has the data in this path. Now, how lies the difference between these two things? Okay, so this time what I'm going to do is I'm going to delete my external table first. Okay, so how do you delete a table is the very simple statement of drop. So it's actually dropping a table. Okay, so drop, and this time I'm going to delete this external table, which was this one. Okay, and when I do this, okay, I'm missing drop table, and you can see that this table is dropped. If I do a show, sorry, not show, yeah, show tables, if I'll do, you'll see that this table is not existing anymore. Okay, similarly, let's just drop the internal table as well. Drop internal table, oh sorry, it was v4. Okay, all right, and if I do a show tables now, you can see that both these table which had data, the Sahil external v2 and the Sahil table v4, which is this one, both were having data in their folders, and now we have actually deleted them, so these tables are not present. But what about their paths and what about the data, right? So if I do an ls on my external table now, you'll see that data is still present in my external table. But if I do an ls on my internal table, what do you think is going to happen, Marcia? Will this data be present now, Marcia?
Sorry?
So as you see, right, we have deleted our internal table, the managed table we deleted, right? And we also deleted the
So,
external table, right? But
hmm,
when I did an ls over the path over which the data was stored in my external table, right, I could see that the data is still present in my external table, right? Now, a question to
hmm,
you is, will the data be present in the internal table path as well or not? So this was my path of
mm,
internal table. Will the data be there or not?
no,
Okay. So why?
because you already deleted.
Right. So this is the
Oh,
difference. Okay. Thank you, Marcy. So this is the difference between an internal and external one. 1 second. So if I do an ls of my internal table now, I think somehow because of the permission didn't got deleted, but the concept is whenever you drop an internal table, its data also gets dropped. This probably is having some issues with this user right now. That's why it wasn't dropped. But in any environment, when you drop an internal table, the data also gets deleted with it. But for an external table, your data doesn't get deleted when you drop that table. And that's why most of the time in organizations, people make external tables, because losing this schema of the data, when I say schema, this complete statement, show create statement that we had, right? So what are the exactly the columns? What are the properties of that table? These all constitutes as a schema of that table. So losing that schema is fine, but losing a very large data, this data.text which you are seeing, right? It could have been in some terabytes, gigabytes as well. So I don't want, like, if I have an administrator who mistakenly drops a table and it leads to the loss of data for me. That's why I tend to create external tables more often, so that even when people tends to delete or drop a table from Hive, the data would still be present in the location where that table was initially made to be present. Okay, so this is the main difference between an internal and an external table, and how you load a data, how you drop that tables, and how you actually manages the to describe the delimitation. Okay, that we did from the like in the previous part of it. Now there is another concept of partitioning. Okay, when I say partitioning, this data that you see, right, for let's say, let's check for the external one. So this, we gave it a path temp dot the slash table name where we were creating that table, and the data was directly placed in that path. But you can make certain partitions over here. So what you can do is, let's make a create, let's just make a partition create table. Show. Okay, so what I'll do is I'll make a partition table this time. I'll use the same create statement, give this table a new name. Let's say we make it partition, followed by the same syntax for columns, followed by row format would be delimited. You can like make it in a capital. These letters can be capital or small, it doesn't matter. Okay, it's case insensitive. Format delimited, fields terminated by, let it be pipe only. And we'll be adding another column, partitioned. Partitioned. Partition by, what is the exact syntax? One second, guys. Yeah, partition by, followed by, this time we'll be giving another column, let's say year. Year, which would be a string, and month, which would be another string. Okay, and just make this table now. Cannot recognize input near partition by. Insert the properties. I think partition by needs to be mentioned before everything else, right after what we have mentioned this thing. Format delimited, fields dominated, partition by. Okay, still some error. Okay, something is missing. No, even with string it should take that, but I guess something. Okay, create table name followed by this partition by this. Create table. Okay. Okay, I think I got it. So instead of this, you have to use this. All right. So we have made our table, and this time we have made it a partition table. Okay, so I'll tell you how exactly the partitioning thing is going to affect how you load the data. So what partition does is, and I've given it a partition of year month, so probably I'm expecting my table to have data every month. Okay, so my data that I want to load into this table would be monthly. So every month when I'm going to load that data, I'm going to mention which month it is and which year of this data is to be added. Okay, so let's just quickly put a data into it. Load data in path. That is fine. This time I need to mention the partition as well. Partition, and I'll mention the partition year being, let's say, 2019 and month being 12, and this will be my table name. Table okay, into table. Partition needs to be mentioned at the end. Syntax, never mind, you can forget the syntax. That's what Google is for, but you need to understand what exactly is the concept of it about. Okay, load data in path, override into this, partition this. Let's see, override load data in Load data in path. That is fine. Into table. Also is fine. Oh, I need to mention the values with describing what exactly a value is for. So year equals to 2019 and month equals to 12. Okay, this time it says invalid path. So I think the data is not present in that path. Let's just put that data again. Put and anonymous chmod chon. Yeah. All right. Now let's just put this data. All right. So this data is now loaded and it's loaded into this partition, which is 12. Now, if I just check show create table, show create table of my this table, which is partitioned. And if I check the path of it this time, you'll see that there is another directory. There are like certain directories being created by partition itself. If I do an ls, so you see there is one directory with year equals to 2019 being present. If I just do it over year, you will see the month directory also being present. So month equals to 12, and in this complete path now would be the presence of my data, which is data.text. Okay, so you can see that since we loaded our data into an partition of 2019 and month 12, this it got loaded in this directory. Now similarly, if I want to load it into a separate directory, let's say if I want to load it into 11th month as well, first of all I need to put the data again. And so I'm not going to do it right now, but you can see that would be another month 11 directory being created and data being present into that directory. Now how does this partitioning helps Hive? Okay, so what happens is it helps to make your search easier and faster. Okay, so if I would like to search data over my 11th month of 2019, right? Hive would have already known that this data is present in this partition of 2012 and 11th month, and it would make your search for that data quite easier. Remember, like consider a case wherein you have a data of which is very large of 2 terabytes. Okay, and in that 2 terabyte data you want to understand what was the transaction that you made. Let's say the data is about your banking history, how many transaction you did in your bank, when was like what all transaction, every transaction that you did with your bank, starting from whenever you had a relation with your bank, is stored in a file, let's say of 2 terabytes, and you want to understand what was the transaction that you made in the year, let's say 1987 or 1993. How would you be able to do that? Okay, so what the Hive would make it quite easier if we had that data in a partitioned form or in terms of year. So your Hive would be aware that, okay, any data that is related to 1993 would be present in that year folder of 1993. And whenever you type something like select, let's say I want to check that transaction, every transaction, select star from my table, whatever be the table name, okay, and table where year equals to 1993. So since if my table had that partition of 1993, it would, this query would not take any much time, and it would be returning the like the answers in like few milliseconds itself. But if that table would hadn't been partitioned right, uh, my Hive execution engine would have to traverse the whole 2 terabyte of data and then figure out what all transactions were made in 1993, and it would definitely make a lot of time for the Hive to be able to do that. Okay, so this is the use of partition. You tends to segregate your data efficiently, and then you tends to get the output also quickly from that data. All right, so this was the concept of partitioning. There is another concept of bucketing, but I'll leave it to you guys because it's a little advanced one, and I haven't used much of bucketing in my organization as well. People generally tend to make partitions only, and that partition is also made in terms of, it could be made in terms of time, or it could be made in terms of year, month, and date as well. Okay, so there are certain tables, for example, in my organization, we tend to load data every day. Okay, so every day at a particular time there a job runs which brings the data from external sources, and we load it into our Hadoop and Hive and through our Hive tables. And what we have, the logic that we have in loading that data is that for every day we make a partition that has a format of date, something like, in the format of date in my partition would be let's say 2019, then the month, then the day. So any table that we have in our organization has a partition of this format, and then we have to place data into that partition. So most of the time you'll see tables with partition being used in many like organizations which handle big data. But there could be a concept of bucketing also present, where you tend to make a bucket further into. So what bucketing is all about is, further into this partition there are certain more directories to present. So let's say in this 1993 I want to just understand what all were the credits into my account. Okay, so what I'll do is I'll bucket my table into further partitions or further buckets of, let's say, credit and debit. Okay, so this 1993 folder will have two more folders, one being a credit folder, other being a debit folder. And when I'll issue a query like I want to understand what all credits were made in my account in the year 1993, the bucketing will further help my Hive execution engine to make my query much faster, because it's now sure, it's now clear that since we want to understand the debits only, so it will directly go into the debits folder and get the data to us. So this is what bucketing is all about, but the syntax and everything I leave it to you. If you want to understand, it's fine. If you want to leave it for now, it's also fine, because it's a little advanced one. All right, so this was like everything about Hive, guys. Any questions before we move on to HD, like HBase? I think you might have to first, try it yourself. Then you'll have more questions out of it. But anything right now, if you don't understand, any command if you want me to give to you. Able to understand, Aeon, Marcia, Saidul?
Yes.
Okay. I want you to try it yourself, okay? Make multiple such tables, delete them, see what happens to the data. Once you delete a table, try to recreate it with the same path, okay? And see if you are able to see that data again or not. So all these experiments, just do it on your systems as well. Okay, it will make you more enrich in terms of knowledge of Hive. Let me share till then these commands so that you can refer. Okay, loading data is fine. Partition table. This is how you load data into the partition table and the syntax of creation. Partition by this row format delimited feeds terminated by. This time I was using pipe, but you can use any other delimiter if you want. Okay, so just try it with these other delimiters as well, so that you are more comfortable to understand that. Okay. Okay, all right. This was about Hive, and so we did all of these things using Hive, so using Beeline. Sorry. Okay. Now, Beeline. When you say Beeline, what exactly happens is, so when I was connecting with a Beeline, right? This was actually my Hive server. Okay, which was, if I show you on the Cloudera manager. So Beeline tends to connect to Hive server in terms of the architect, the Hive architecture. If we discuss, so Beeline tends to connect to this Hive server, and then which internally connects to the Hive metastore. Okay, so this is a tool which most of the time people use, but sometimes if your Hive server is down, let's say this Hive server is down for some reason, you can still connect to your Hive metastore using another command. Just simply type Hive, press enter, and you'll enter another shell, which is quite similar to what it was showing on a Beeline, right? And all the such commands that you were doing on Hive, on Beeline, you can do it from the same shell as well. But most of the time, it is not recommended. It is a depreciated one. You can see a warning also appearing that Hive CLI is depreciated and migration to Beeline is recommended. So most of the time, people tends to use Beeline only. But in let's say when your Hive server is down in your environment, in your organization, and you still want to connect to the Hive, you can use this. Simply type Hive and press enter, and you can do the same things you were doing on Beeline over here as well. Okay, use Sahil DB. Okay, so all those tables and everything that we can, so everything is like this is the master daemon or master server for your Hive, and everything that you create either from Beeline, which connects to Hive server, or by directly connecting to Hive, it will all be reflected in the the same common place only. So all those tables that we created using Beeline are present. There are a few more helpful things available uh, for you to work when you are on Hive shell. Uh, One such thing being this property. Okay, what this property does is the current DB that I am into. So I am currently into Sahil DB, but it is not showing. If I just press Control L, and I'm not, I will be confused at what is my current DB, in which DB I am currently present into, right? So I can show that directly by using this property Hive CLI print current DB equals to true. If I just enter it, now my Hive shell will show me the DB that I'm currently into. For example, if I now switch to, let's say, default DB, it will start showing me default option. Okay, so using this property, you can print the current DB that you are into the Hive shell. Okay, but this is being like this. Why I'm telling you that this is a depreciated version of connection. Why Hive is a depreciated one? Because it's quite heavy. I've mentioned certain shortcomings also. Although like people won't ask you this thing, but for your understanding, it's a very fat client. It's very heavy execution, and all the compilation, optimization mode. So all of these are like stages. Whenever you type any query of Hive, right? If I type anything like select star or select something from my tables, right? So all of these things, for example, show tables. If I do a select star, right, this whole thing will be compiled first at the back end. When I say compiled, select star from, let's say, my this table. So at the back end, what happen is this is an English like statement. It's quite English like, right? So select being an English word from, select star from this. So all of this will be converted to do a machine language, and that is what compilation means. Okay, so all of this will be first changed to the machine language so that Hive server can interpret it, or sorry, Hive Metastore can interpret it. Then there could be some optimization being done, so that optimization, when you talk of, since you have already mentioned the partition column or bucketing column, I will make it this search optimize in that sense, so that it is making it's going to make it take less time. Okay, so this is what optimization means. And then monitoring means what is the current status of running my query. So my query could be, it could take some time. So what is the current status where my query has reached at a particular level. So all of these stages in Hive shell, what happens it, they are all done on the local machine itself. So on this machine, on this server from which I have opened the Hive shell, right? From which I have opened this Hive shell, all of these things of compilation, optimization, and monitoring will be done on the same server. And the drawback of that is that my server would be utilized for its memory and resources, which I don't want. I want my whole cluster to be utilized instead of just a single server, which is the local one being utilized. And that's where Beeline and Hive server are beneficial. Okay. you tend to connect through a beeline. You tend to do all these stages of running a query on a cluster instead of on the local machine. So that's why the CLI Hive, we call this the CLI as well. This is a Hive CLI, is a little not recommended, and that's why you tend to connect to beeline. Okay, this was about Hive now, and similar to this is another thing which is Impala. I don't think I've added Impala in my cluster yet, but Impala gives you a much more efficient, even faster way of connecting to Hive and get your results. I haven't added Impala yet, but you can add Impala from here. Add service. There could be an option for Impala. Yeah, here it is. So I'll not be adding it right now because I don't want to utilize my space. But you can add Impala in your clusters, and the queries would be it would be quite similar to what you did on Hive Shell, or what all queries you were able to do it in Beeline, right? So you can do the same things in your Impala as well. And just what is like, it's an advantage of using Impala is that your select queries in your organizations would tend to run faster. So all these queries like select star from this, select star from that, it tends to run faster when you are on Impala shell, and that's why it's a little beneficial in that case. But that being said, what all you need to learn right now is how you, all the things that we did, right? So creation of tables, loading of data, then selecting, dropping, what is an external table, what is an internal table, what is the difference, all these things you should be uh, like quite aware of. And all the things like I told in terms of Hive CLI, in terms of Impala shells, they, you need to understand that they are a little efficient way of doing it. Installation and every part is quite similar. You just need to add a service from this option, and then you can start using the services from your end. Okay, so I think we can leave it till now, till this point right now. There's another option. There is another like the last topic which is left is, in terms of Hive, is configuring an HA or a proxy. So when you say a proxy, what happens is you can have multiple Hive servers. I have given a URL for you to understand this thing. Okay, let's open this URL. So over here you can see how, what are the steps of you to install and manage proxy. So you just need to do first install a package which is HA proxy, and then you have to configure a file wherein you need to mention your Hive server 2. Now let me explain what exactly is proxy. For example, let's say you have all these instances, you have multiple Hive server 2 present. Okay, since right now I only have one Hive server 2, but in an environment where my cluster is need to be used by, let's say, 1,000 or 2,000 users, right? So I would make many Hive servers, many such Hive server 2 available, so that many people are able to connect to my Metastore and run their queries. Now let's say we have 5 or 6 such Hive server 2 present over here. If I just keep on adding Hive server 2 from here, right, they will keep on increasing. Now instead of every time, so when we were connected to Beeline, we were giving this Hive server URL, right? we were giving this IP address of my Hive server to connect to. Now, if I'll have if I let's say I have 5 or 6 such Hive server 2, for my each user, I have to give a separate Hive server 2, or even the same can be done, but I want to distribute the load. That's why I have it like I added Hive server 2s, multiple Hive server 2. So to distribute that load into all of these 5 or 6 Hive server that I have, I would have to give separate URL of the Hive server 2 to every such user I want them to connect to, right? So this was the URL for my this server. For other server that I add will have a separate URL, and this connection string will keep on changing, right? Now to prevent such scenario and to make a common connection string for everyone, so that I can give just a same connection string to everyone, and at the backend what happens is that string would automatically decide which Hive server 2 it wants to connect to. Okay, for that case we configure a proxy, and what proxy does it gives you something like a load balancer, Hive server load balancer property. In the configuration you can set that. Once you did all these steps, right, so you need to like, you would have to install this part, then you will have to change the configuration, you will have to mention uh, what all Hive server 2 you have. So over here you will be mentioning this Hive server name, which I showed you in instance. Then the next Hive servers that you have, you all need to mention that stuff. Then you have to like start it, HA proxy part. Once you have started it, then since all of this we have replaced with, let's say, a server, let's say this would be the proxy name, this would be the other server, the Hive server that we have, they all will be known by a single proxy server. Okay, and in the configurations you have to mention just that in this property, which is Hive server 2. So I would mention something like server, which is my proxy name I had mentioned in this configuration file. Okay, in this configuration file I had mentioned that this is my proxy name, and just mentioning that proxy name in my load balancer. Now all my connection string like this over here would be replaced by something like server. Okay, so this would be my common string, and at the backend what this thing would, what the HA proxy this service would do is it would load balance. When I say load balance, it would decide which of these Hive server would be connected to by that connection, by this connection, depending upon the load on the Hive server. So let's say if I had 5 such Hive server over here, and server 1 is like mostly utilized right now, but server 2 is not much utilized, so that load would be transferred to server 2, but the connection string would always remain same. Okay, so this is also a little advanced stuff, but it is something that can be asked if you any of you will go for a certification, right? Hadoop certification. All of these topics, like this topic is also mostly asked how you set up HA proxy. Organizations, in terms of organization, although I don't think many of them have HA proxy available, but yeah, this is something that can be asked in your certification or interviews. So a little idea of it, what exactly it is and how it is done is also fine. And if you want to implement it in your cluster and see how it works, then this is the URL that I have mentioned in this document. Just refer it and try to uh, install a proxy onto your systems as well. I'll leave you to I leave it till Hive only for today as well. Okay, I want you to do all this stuff that I did on your systems and servers as well. In next class on Wednesday, I'll be covering with HBase. So I'll suggest, because this HBase is a little vast topic, okay, and it's vast in terms of theory more. Practically, it would be quite similar to how you be used Hive, okay. It's also just about creating tables in HBase and loading data in HBase as well. But in terms of theory, it's very different from Hive, okay. So you need to be careful. you need to be a little theoretically careful in the next class of HBase, wherein we'll be discussing what is the architecture and every stuff. So I would suggest once you are done with this, at least give a read to what I have mentioned in this HBase part. Okay, just a little read would make you a little more aware of whatever things I'll say in next class about HBase. And in next class, I think we'll be covering HBase from till end. But till now, I'll leave it to this topic. Try it yourself. Come up with questions and doubts, if any, once you have tried it. Okay. I think you still have 2-3 days before we meet for HBase, and experiment more of Hive tables for now. Keep on changing stuff like this. Keep on moving it or like on separate parts, so that like place this row format limited before this and see what error you get. So all those such experiments would make you more aware of what exactly can go wrong and how you to make that right. Okay, any questions till then, guys? Any part you didn't understand? I think you would like understand it more when you do it yourself. Okay, so the task for you for today is internal and external table you were able to create last time. Yeah, okay. So internal external table you were able to create last time, but today you will make it with a delimited. So when I say delimited, so you'll have to mention something like row format delimited fields terminated by, in double quotes, you are terminating your fields. Okay, then create a file, load that data into your table, see if with a select star from your table name query that all that data is appearing fine into your table. Okay, after that, if it doesn't appear fine, just see what exactly went wrong. Just come up to the video and check that. Okay, the video will start appearing in around 2-3 hours because it takes some time for me to process the video. But before that, you can refer any other URLs. You can refer this page. This page is already updated, and all those commands is already present on this. I think it keeps on changes as saving as well. So you can refer this page and you just keep on. Okay, so creating that table, loading data into both internal external, then drop that these two tables and see what happens. After that, create a partition table, add data to the partition table, run a query over that and see what happens, and then try to connect to a hive shell and use that property which I mentioned over here and see how it makes your DB starts appearing, this property. Okay, it's in the Hive part, just at the start of the Hive part, and see how it works, and try to run the same commands from Hive shell as well and see what happens. That would be all for up till like Wednesday, and in the next class we'll be starting with HBase. Just give it a read as well at any time you want. Just try to read this this part of document that I mentioned for HBase as well. Okay, so if you don't have any questions for now, let's just stop it and meet in the next class. All right, bye guys, goodbye, good night.
Right.
Yeah, thank you.